Hello everyone, welcome to another video. In today's video, I am going to show you a fully automated production grade DevOps CI/CD pipeline. So it's going to be a hands-on project, and as you can see in this repo, I have mentioned each and every technical step that you have to follow to replicate this project in your own lab. Okay, so in my last video, I discussed about the theoretical aspects of a production grade DevOps CI/CD pipeline. So a lot of people reached out to me saying that please try to do a hands-on project and show it to us. So that's why I'm doing this video. All right, so let's get started. So if I talk about why we are doing this project, so what's going to be our problem statement? How to deploy a fully automated production grade DevOps CI/CD pipeline. So if you replicate this project in your own environment and make notes on it and just explain this in the interview, I think you're going to crack most of the DevOps interview, if not all the interviews. All right. So in this project, I am going to use a few tools and technologies. Okay. So let's talk about that first. So I'm going to use a GitLab as my source code management and my CI, which is continuous integration platform. Then I'm going to use Argo CD for my continuous delivery platform. So actually, I'm not doing continuous delivery here. I'm doing continuous deployment because I won't have any manual step in this project. So the pipeline is going to automatically deploy to our cluster. Okay, so let's just edit it. So I think you already, a few of you already know that when we have continuous delivery, we do have a manual approval before we deploy to our clusters. Okay, but in case of continuous deployment, the uh, deployment happens automatically without any manual approval step. Okay, so it's going to be a continuous deployment project. All right, then in this project, I'm going to be deploying a front end application, which means that if you know, each application has multiple tiers. So in this project, I'm going to use a front end application. It's going to be Apache web server. Okay, a very simple Apache web server, but it's going to be deployed via a CI/CD pipeline. Okay, and the application is going to be containerized as pods, and it's going to be deployed inside an AWS EKS cluster. Okay, the EKS cluster that I'm going to use will be deployed via Terraform IAC, infrastructure as code, and also we'll be utilizing snyk tool. We'll be utilizing the snyk tool to scan our container images, which is built for security vulnerabilities. Then our container images will be pushed to an AWS ECR private registry. Okay, so after we have uh, built our images, it's going to be pushed to ECR, a private registry. Okay, and as I mentioned, this DevOps CI/CD deployment pipeline is going to be fully automated. If I talk about the application architectural diagram, okay, so this is how it's going to look. Let's just zoom in a little. So I zoom out a little. Yeah. So it's going to have multiple stages. So as soon as any developer makes any changes to our GitLab source code management repository, okay, so any code change pushed is going to trigger our fully automated CI/CD pipeline. Step one is going to be we are going to check the EKS cluster status. The EKS cluster should be in ready status. It should be healthy, which means that it should be ready to deploy the application. So we are going to test that in stage one. Stage two is going to be where we are going to check our syntax for our Docker file. So the Docker file that is going to be used to build our Docker image. So in stage two, we are going to test its syntax if it's correct. Then after this stage passes, we are going to trigger a CI build. So we are going to build our container image from this Docker file, okay, and the image will be built after this step. Once we have the image, we are going to push that image to a private container registry in Amazon ECR or Elastic Container Registry. And once we have our image pushed here, then we are going to scan that image for security vulnerabilities. So we'll be using this snyk open source tool, okay. So we'll be using this tool to scan our container image, and once it passes this stage, then we are going to use Argo CD to deploy this newly built image to our EKS cluster, okay. So this is how our production grade CI/CD pipeline will look like. So it will have these multiple stages, okay. So let's see next. So let me just zoom in a little now. Yeah. So as I mentioned, all the steps, each and every technical step that you need to do a hands-on project on this project is given in this repository. So let's go step by step. So step one is to administer. So to administer the entire DevOps CI/CD pipeline, I'm going to use an AWS EC2 instance. EC2 instance is going to be t2.micro instance type. I'm going to use Ubuntu 24.04 LTS AMI, but if you want, you can use some other VM on any other cloud platform like Azure or GCP or any other cloud platform. Okay, it does not matter. Once you are SSH to the machine, it's going to behave in the same way. The only difference is I'm using ECR, which is also in AWS. But if you want, you can use some other container registry platform as well. Okay. So this instance which I'll be using to do all the work related to this CI/CD pipeline. So this instance is going to function like a bastion host, or you can say it's a jump server, which we generally use in production also. We have one main server where you log in, and then from there you do all your work. Okay, so this instance will be working as a bastion host, also called a jump server, where we will be deploying all our resources from. Okay, and also you need to ensure that this EC2 instance has an IAM role attached to it, okay, with some permission policies that are required for this project. So here I've given the screenshot. These policies are AWS provided. So you once you are in IAM, I'll just show you as well. In IAM, you can attach all these policies. Okay. Apart from this above mentioned managed policies, you also need to attach one custom IAM policy. That policy is already attached in the repo. You can see that. Okay, if you just go to the home page of this repository, you will find one file. It's called EKS cluster policy.json. So this is going to be a custom policy, so you can use this, and you need to attach it to the IAM role that will be attached to your EC2 instance, the bastion host. Okay, so this is because we will interact with our AWS account via CLI while working on this project. Okay, so if I can just show you in my AWS account as well. So this is the machine that I'm using. Okay, and in this machine you can see the role is EC2-SSM. Okay, this role has certain policies attached to it. So you can see all our AWS managed policies, the first 1, 2, 3, 4, 5 policies, and one is customer managed policy, which is EKS cluster policy. So this policy is already attached in the repo. So you can copy this policy, create it, and attach to the IAM role that you want to attach to your EC2 instance. Okay, which I've already done, as you can see. Okay, so this is the IAM role that I'm using, and this is my instance which I'll be using to do all the work. Okay, and here I've already logged into this machine. Okay, to save time, so I'm already logged into this bastion host with that IAM role, which has all the permissions we need to create all the resources required for this project to complete. All right, let's go to next. So up to here we are already done. Then step 2, as I mentioned, SSH to this instance and follow the steps below to install Terraform and create AWS EKS cluster. So the first thing is I will log into the instance, okay, and I'm going to install Terraform here. So I'm using this official documentation. You can open it and check the steps also, okay, but anyways I mentioned everything here. So I mean I've mentioned this URL that you can use to find the steps that you need to install Terraform on this instance. For example, if I just show you as well. So I'm using Ubuntu Debian instance, okay, so I can just copy this, go here and paste this. So it's very simple to install Terraform on an AWS EC2 instance based out of Ubuntu, okay. So just copy this step first, this particular command, and then the next command from here. All right, next is, okay, it's not required. If you want, you can run this command, it's not mandatory. Update, run the update to update the package index on your machine. So okay, it's going to update the package index on your machine, and next is to install a Terraform command, a Terraform tool. Okay, so I've already installed on this machine, so it's showing me as a Terraform is already installed, but in your case it's going to install Terraform. Okay, it's done. Installation of Terraform is done. It's pretty simple, only 3-4 steps from the official documentation of HashiCorp. Okay, then you have to install Git tool. Okay, so to install Git, you can copy this command from here, go here and paste. So Git is also already installed on my machine. Then I'm going to clone this repository. Okay, so I installed Git so that I can clone a few repositories I need to accomplish this project. So the command is going to be git clone, git clone, and then the repository URL. So this is the repository that you can use to create your Terraform based EKS cluster. Okay, so so if you see this particular repository has all the things you need to create the cluster. You don't need to do anything, you just need to clone it and run the standard Terraform commands to create the EKS cluster in your account. The only condition is, since you will be using it via CLI, your AWS instance should have all the permissions you need to create the cluster and all its resources. Okay, so that's why I mentioned at the start that you have to attach an IAM role. We should particularly have all these policies attached. Only then the cluster will be created successfully. Okay, so just ensure that you have that IAM role attached to your instance with all these policies attached. Only then you will be able to create the cluster without any issues. All right, so if I go here, if I do LL, you can see I have already clone the repository. Okay, so I don't need to do it, but you can just run this command. It's going to clone the repository to your account. So this is the repository I cloned. So let's go inside this EKS cluster. Okay, so cd into EKS cluster. If you see, I have mentioned each and every step that you need to do on this project. Okay, so you don't have to look anywhere else. All the things, each and every step that you have to perform is given in this repository. Okay, so you can replicate everything. Okay, so after going into this EKS cluster folder, after you have cloned the repository, you have to run Terraform init command to initiate the Terraform backend. Okay, so do Terraform init. It's going to initialize the backend for you. All right, it's done. Next is you have to create the resources. Okay, so I'm not using a Terraform plan here. If you want to see what all resources you want to create, you can do that. Okay, or you can simply run Terraform apply auto approve. Okay, so this cluster that I'm creating, I'm using the default VPC. Okay, and I'm using two availability zones. In those two availability zones, I have two subnets, so I'm using that. But if you want to change that, you can do that. So if I just show you the files also, how this cluster is going to be created, so you can check the main.tf file. Okay, so you can do some customization is what I mean here. If you want to use your custom VPC, you can do that. Okay, but I'm using the default VPC in this case. Okay, so the motive of this video is to show you how the different stages of a CI/CD pipeline is built and run to deploy an application to an EKS cluster. Okay, so but we know that the pipeline has various stages, and it has various components to it. But if I cover all of the things, then it's going to be like 4 or 5 hours of video. Okay, so I just want to uh, focus on the pipeline stages in this project. But if you have any doubts related to any of these files, you can reach out to me and I'm going to answer all your queries. Okay, so this is the main.tf file, and if you do have other files as well, for example, if I just show you a terraform.tf vars. So here you can see I'm using two subnet IDs. Okay, so these are the IDs from my AWS account. So of course you want to change that. So just ensure that you have changed it to two subnet IDs from your own AWS account. Okay, so you have to change these values, else it's not going to work. Then this is the name of the cluster that's going to be there, and it's going to be in environment dev. So these two are the tags. Okay, so and similarly you can check other files as well, and you can make the changes if you want to in all these files before creating the cluster. Okay, after you do that, you can run this command to create the cluster for you. So copy, enter. So it's going to show you if the current configuration does not match the Terraform state file, and then it's going to create or delete the resources accordingly. But in my case, I have already created the cluster just before this video, so it's showing me no changes. Your infrastructure matches the configuration. Okay, but in your case, it's going to create the cluster, and it's going to take some time also. Okay, it generally takes like 10 to 15 minutes for the cluster to complete. So be very patient after you run the command. Just wait for 10 to 15 minutes and then come back and you will see your cluster ready. Okay, so after you have created the cluster, you can check in your AWS account from the UI to check if the cluster was created or not. Okay, so this is my AWS account, and if I go to my EKS service, so you can see the cluster is created. Okay, demo-EKS, and you can see all the resources that are created as part of this cluster. Okay, so this is step G here. Step G, to check the cluster status from AWS UI. Okay, then you have to install kubectl, because we'll be using a lot of kubectl commands here to interact with our EKS cluster to perform a few steps a part of this project. So you have to install kubectl as well. So I've given the command. Okay, you can copy and paste the exact command from here, run it here. Let me just go to my home directory and then run the command. Okay, so it's going to curl this package to your machine, and then this command is going to change some permissions required on the executable file kubectl, and make it functional for you. Okay, so you can just run this command like this. All right, this is done. and if you run kubectl now, you should be able to. Okay, so kubectl is installed. Next, I'm going to install a package unzip, because after kubectl I have to install AWS CLI as well. So we will be using some AWS CLI commands as well. So to install that, you need unzip package first. So just install unzip package. So copy and paste the same command from here. Okay, so unzip package is already installed on my machine. So this is one command, copy and paste. Done. Then we will unzip this downloaded package. So I've already installed AWS CLI, so I don't need to do that. Okay, but in your case, it's going to be the first time, so just install it. And I think it's not going to ask all these questions when you install. It's going to simply install all these different packages as part of this installation straight away. Okay, but for me, since it is already installed, it is asking me to replace these. Okay, so just run this command to unzip all the packages, and then you have to execute this. Now just run this. Alright, so we as I mentioned, I already have this AWS CLI package installed, so I don't need to do anything. Okay, so AWS is installed, so you can just run this AWS command to verify. Alright, then next, so the EKS cluster is ready. I've installed AWS CLI, kubectl. Okay, now it's time to connect your created EKS cluster with GitLab. Now you can create your own GitLab server as well, like the self-hosted GitLab server, or to get started quickly, you can use the official gitlab.com website as well. So in my case, I'm going to use this gitlab.com website to connect my EKS cluster to and deploy. To use it as my CI platform. Okay, so so what I'm going to do is I'm going to first sign up on gitlab.com. So let's go to gitlab.com now. So here, as you can see, I've already logged in, but if you just log in for the first time, okay, so or if you just try to access this website for the first time, for example, if I do it on an incognito window, it's going to ask you to sign up. Okay, so it's a simple process. You can just click on sign in and use your email ID. You can use your email ID to complete this sign in 2 steps. Okay, so that's what I'm using. So I logged in with my Google account only, so you can use the same. Okay, and once you do it, you will be redirected to this page here. Okay, the default page after you have signed into this gitlab.com. Okay, so this is like a very good way to get started with GitLab, where you don't have to manage this server on your own. Okay, so you don't have to create a self-hosted GitLab server. You can use this gitlab.com website, and it works. It's exactly the same way as a real production based GitLab server works. Okay, so after you have done that, so we have created our EKS cluster. All right, EKS cluster we have already verified. It's there. It's working. Okay, the cluster is ready. We just need to, what we have to do is, since we will be deploying our resources via the CI/CD pipeline steps, okay, to this EKS cluster, we need to have these two platforms integrated with each other. Okay, so your gitlab.com account should be integrated with your EKS cluster, so that you can deploy resources into EKS from your GitLab pipeline stages. So how you're going to do that? So you have to integrate these two things together. So for that, we have official documentation as well. Okay, so step 3 is going to be connect your created EKS cluster with the GitLab server. Okay, so you can just open this documentation also. how to connect a Kubernetes cluster with a GitLab. So it can be any Kubernetes cluster. You can create your own Minikube cluster as well, or if you want to create a cluster on some other cloud platform, Azure or GCP or any other cloud platform, you can do so, and you can create and you can connect that cluster with your GitLab account. Okay, in my case, it's going to be an EKS cluster. Okay, so all the steps are mentioned here, but sometimes it is just too much information to absorb and follow. So just to make it easier for you, I have given all the steps step by step. You have to follow here, and you will be able to connect your EKS cluster with your GitLab account. Okay, so how to do that? First thing is install the Kubernetes agent for GitLab. So this is step one. So to connect this EKS cluster with GitLab account, you have to install a Kubernetes agent in your GitLab account. Okay, uh, but the first thing is you should confirm that you are able to access the EKS cluster. Okay, so how to do that? So after the creation of the cluster, what you have to do is so you have to run this command. Okay, this is the command which is going to create the kube config uh, to authenticate to your EKS cluster, and you can access the cluster from CLI. Okay, but you should install this kubectl as well, so which I've already done. Okay, so now just run this command like this, and okay, so I think what you have to do is region. It's going to be, so I'm creating all my resources in US East 1 region. You can use the same, or you can choose a region of your own choice. Okay, and this is going to be the name of the cluster. So name of the cluster you can check from your Terraform configuration files, or after the creation you can check in your AWS account as well. So in my case it is demo-eks. Okay, so it's going to create the kubeconfig file required to authenticate to the cluster from this machine. Okay, done. Then after this you can verify if you're able to access the cluster using uh, kubectl get node command, get nodes command, the standard kubectl command to check the status of the nodes. Okay, so if you're able to view this means that you are able to access the EKS cluster nodes, the worker nodes, from this machine. Okay, which I am in this case, as you can see. Okay, this is done. So this is step one. Okay, so this is again a part of how you can connect your EKS cluster with your GitLab account. The first step is to install the Kubernetes agent, and for that you have to verify if you're able to access the cluster. To access the cluster, you have to use these two commands. Okay, now as I mentioned, you have to sign up or use your email to log into gitlab.com, which I've already done. Okay, as you can see here, I have already done that, and I'm able to access my GitLab account on gitlab.com. Right, then inside this GitLab account you have to create a new project. Okay, so how to create a new project? You can go to this new project option, create a blank project, and then put the name of the project that you want to use. Okay, and keep it public. Okay, that's what I've been using, so just keep it public, and you don't have to do anything, and just click on create project. Okay, in my case I've already done that. If I just show you, so after you click on this create project, you can go to your personal tab, and you can see the class, the project has been created, EKS project. Okay, so this is the next step. Create a project called EKS on gitlab.com within your account. Then in the repository, in the repository of this new project, you have to create an agent configuration file. Okay, at the root. So you're going to do that? So this is my project. Okay, so what you have to do is you have to create a new file. So you can go here. Okay, and you can click on new file here, and then you can copy this entire name of the file as given here, like this. So as I mentioned, all the steps are mentioned here. So just copy this and go to this project root and then click on the new file and then just type the name of the file and click on commit changes. Okay, after you do that, you will be able to see this config.yml file created inside this directory, inside this project at the root. Okay, so this is what is required to set up your Kubernetes cluster with GitLab account. Okay, so this is how you have to create the file. So inside this you will find this file. This is a blank file actually, but you have to create this file as it is given in the official documentation here. Okay, if you just go through the steps, you will find one step mentioned where you have to create this blank configuration file for your Kubernetes cluster. Okay, so after you have done that, after you have create the agent configuration file in the root of this EKS repository, just leave this config.yml file as blank. Okay, and then you have to register the agent with GitLab. So how you can register the agent? After you have created this project, okay, just go to the root of this. Okay, and then on the left hand side you can see the option of operate. Just go to operate and then click on Kubernetes clusters. Okay, so this is the way you add a cluster to an account, okay, to this GitLab account, but you have to create one repo also, and within the repo, when you go, you will see all these options appearing. Okay, so click on this Kubernetes clusters. In my case it is already connected because I just did it. Okay, but how to do that, let me just show you. So as I mentioned, once you are inside the root of the project, on the left hand side from operate, go to Kubernetes clusters. Okay, then you can click on connect a cluster like this. Okay, and then name the agent. Okay, let's see what name I've given. I've given as EKS, so just type EKS here like this, and then click on create and register. Once you do that, you will see this screen popping up. EKS successfully created, and you will get one agent access token, and you will get some Helm commands like this. Okay, popping up. So what you have to do is you have to just copy all these commands from here. Okay, on the screen, when you just click on the this connect the cluster, you will see this pop up, and you can copy all the Helm commands from here and just paste it in some safe location on your machine. Okay, once done, then you have to install Helm on your Bastion host. Okay, so here on this machine you have to install Helm also. So to install Helm, you can use all these commands. Okay, so once again all the commands are given here, so just copy and paste, enter, run these commands in sequence, and Helm will be installed on your machine. Okay, very easy. So this is the script that is going to install Helm on your machine. Okay, Helm is already the latest version, so I've already installed Helm, so it's showing the message that it is already the latest version. But in your case, it's going to be the first time, so it's going to be installed. Then after installing Helm, you have to add this repository. Okay, so let's see here. So as you can see, after installing Helm, you have to perform all these steps which were popping up, so which we have already saved in a safe location, right? So you have to run these commands after installing Helm. You have to run all the Helm commands one after the other. So this is the first command. In my case, it is already already existing. In your case, it's going to be the first time, so it's going to be added to your Helm. Okay, then you can run this Helm repo update, which is going to update your Helm with the latest repository that you have just added. Okay, Helm repo add. So as you can see, I already have this, so it's saying GitLab already exists. Okay, in your case, you will not see this error message. Okay, so after this, after adding this repository, updating your Helm repo, then you have to run this last command, Helm upgrade, this command from here. So this command is the entire command, so you can run it in one go, copying from here till here. Okay, I've already done that on my machine. Okay, so this command I've already run, so it's already configured. And then after you run these three commands, 1 2 3, then you can go to your gitlab.com and just refresh the page, and you will see the EKS cluster is connected. Okay, which means that all the steps that you performed were right, and you are able to connect your EKS cluster with your GitLab account. It's pretty straightforward. All right, done. Next is we will install and access Argo CD on the Bastion host. Okay, so now it's time to install and configure Argo CD, which is going to be our continuous deployment tool. Okay, so you have to run this command to create the namespace. Okay, I've already done that on my machine. Okay, so it already exists. So what it's going to do, it's going to create the Argo CD namespace inside your EKS cluster, since you are able to access the cluster from here, remember. So whatever commands you run with kubectl, you're interacting with that cluster only, and whatever resources you are trying to create, you're trying to get the resources in that EKS cluster. Okay, so run this command and then apply this. Okay, and then you can check the status of all the pods in this Argo CD namespace. So first thing is we have to create the Argo CD namespace. Then we are going to run this standard Argo CD command to install all the resources in this new Argo CD namespace. And then using the third command, we can check all the status of all the resources that were created as part of the installation of Argo CD. Okay, so you can see the status of Argo CD. Okay, so after you ran those two commands, you will see all these resources created in Argo CD namespace. And then since after installing Argo CD, by default you don't have access to the Argo CD server, okay, outside the cluster. So to expose this service outside of the cluster, you have to run this command. It's going to patch your service. Okay, the meaning of this patching is I'm trying to update my service type in Kubernetes. So I'm trying to use a load balancer type of service to expose my Argo CD server service outside of the cluster, so that I can access it and I can create my application. Okay, because we have to create one application on Argo CD that will be later utilized by a CICD pipeline to update and sync, okay, with our new changes. Okay, so you can run this command. In my case, I've already done that. Okay, so if I can show you, you can do that. This kubectl describe. You can do kubectl describe svc for service. Name of the service is going to be Argo CD -server service. This one. Okay, Argo CD -server service, and it's in the Argo CD namespace. So you can see the namespace has been patched. Sorry, this service has been patched with load balancer type of service, and you can see that the load balancer DNS name appearing here. Okay, so after you run this command, run this command, it's going to create a load balancer in your AWS account that is going to be used to access your Argo CD server inside the cluster. Okay, so to verify that, you can go to your AWS account as well, as I mentioned in the documentation also. You can go to your AWS UI, you can go to load balancer section, and you can check this new load balancer created to access your Argo CD. Okay, so this is created. Okay, and yep, so you can access this DNS name to access your Argo CD cluster. Okay, so if I can just show you. So I'm not using any certificate here. It's HTTP based URL, so it's going to show you the warning. you can proceed to it, and it's going to show your Argo CD. Okay, so this is the Argo CD page that you are able to access outside of the cluster after you expose the service via load balancer. Okay, this is done up to here. The load balancer DNS name will be the Argo CD server URL with default user set as admin. So after you create this Argo CD in this way, the default username that is there to be used is going to be admin user. Okay, and to access the this Argo CD server, you have to use username and a password. So to retrieve the password, you can run this command. You can copy this entire command from here to here, copy and paste it here, hit enter, and you will see one password appearing. So this is the password that you can use with admin username. Okay, so it's Ubuntu user, so it's up to here only. Okay, so just be aware of this. I'm using Ubuntu user, right? So the password is up to here only. Copy, type admin here, and just paste the password that you just copied from your Passion host and hit sign in. You will be able to access the application. So you will be able to access Argo CD, and this is the application that I created, okay, which I'm going to show you next. Okay, so after you've done that, after you are able to access your Argo CD with the admin user and the retrieved password, you can log into it. Then step 5 is create an IAM user and assign administrator access to it. Then generate AWS access keys and save it somewhere safely. These access keys will be used to authenticate to the GitLab server. So now what we're going to do is we are going to create an additional IAM user, okay, in our AWS account, okay, and we are going to assign administrator permission to it. Only administrator access permission is required, and then you are going to create one access keys for that user. Okay, so let me show you that also. If you go to IAM in users, in my case I have already done that. So this is the user that I created, admin John, and it has administrator access permission. So similarly you have to create one new IAM user, okay, assign administrator access permissions to it, then go to security credentials and create one access key pair for it. In my case I have already done that, but in your case you can click on create access key and create the new access key using this option. If you click on next, just click on understand, next, and then just click on this create access key, you will get one .csv file. So please download that file to your machine, okay, and then you can retrieve the access key ID and secret access key from that file, which we will be adding to our GitLab account, so that when we run our GitLab CICD pipeline, we are able to interact with our AWS account using those access keys and administrator permissions. Okay, so this is next step. After you have done that, create an AWS ECR repository in your AWS account. Okay, so you can navigate to AWS ECR. So now is the time to create the ECR repository that will be used to store our container images. So you can go to this ECR service from here, from the search box. Okay, when you click on it, you will reach this page. Okay, and then you can click on this create repository, give it a name. It can be any name. In my case it's DevOps CICD, and then just click on create button. It's going to create the repository. Okay, pretty simple. And I've given the screenshot also how you can create this ECR based container registry. Okay, so this ECR registry will be utilized to store our built container images from the pipeline. Okay, then step 7 is to generate the SNIK token. So as part of our CI/CD pipeline stages, we have a SNIK stage where we are going to scan our container images. So to enable this pipeline stage to be able to scan our container images, we'll be using a SNIK token. Okay, so we can use SNIK tools open source version which is available, and we can generate a token there and use it to authenticate from the GitLab server to the SNIK server to to perform a scan on our container images and share the results with us. To do that, what you can do is you can click on this page from here. Okay, so this is going to take you to this page, and you can you can create an account on snyk tool. So this is the official snyk open source page. So you can sign up with Bitbucket, Google Enter ID, or Docker ID. Okay, in my case, I use my Docker ID to do that. So it's up to you. You can use any of the account. You can use a Google account also to do so. Okay, so after you do that, you'll be taken to this screen. Okay, let me show you that also. I think I use my Google account, not Docker ID. Let's just confirm. Yep. Okay, so I just clicked on that Google button to use my Google account to authenticate to this snyk account, and here you can just click on this option here, and this is going to be your snyk token that you have to copy and paste it in a safe location on your machine. Okay, so just copy and paste this, store somewhere. Okay, save the token, and it's going to be later used with GitLab. Okay, so all these different tokens and access keys are required for our pipeline stages to authenticate to these resources from the pipeline stages. Okay, so when we are running the automated pipeline, it should not face any issues with authentication. So we are trying to generate all these tokens and access keys so that our pipeline can interact with these different tools and websites. Okay, to do what it is supposed to do. Okay, then step 8 is going to be follow the following steps to clone the application repository. Now is the time to clone the main application repository, which has our source code, our Docker file, our gitlab-cin.yml file. Okay, so all those files are there in the repository, which is already there that you can use, and this is the address. So you have to fork this repository. Okay, so once you are inside your GitLab account, this is the repository. Okay, you can click on this fork button to fork the repository. It's going to fork the repository for you. Okay, but as I mentioned, I'm seeing some issues here. I've already done it once, so I'm not able to fork it again, but for you it's going to work. So when you click on this fork button, you will see this type of screen appearing. So you can just give it another name, any name, and just click on fork project. It's going to just clone the repository to your account. Okay, then after this what you have to do, you have to go to your bastion host and run these commands. So it's going to, so what I'm trying to do here is I'm trying to create a new folder with this name. Okay, so in my case I've already done that. Okay, so create a new folder, then go inside the folder. Go inside the folder. So in this case I'm using CICD new -2, but you can use any name. So in my case I used CICD new folder. Okay, so once you are inside the folder, you have to go to this argo-app. Sorry, you have to clone the repository first. Okay, in my case I've already done that. If you just do ll here, so I've already cloned the repository. Okay, but in your case you can run this command to clone the repository. Okay, yeah, so you have to clone this repository. Once you do that, you can go to this folder argo-app. Okay, which is part of the clone project, as you can see. So you can go to this cd argo-app, and here you have to run this command to create the Argo CD based application. Okay, so the YAML file is already there. You just have to create this application using this command. Okay, so when you run this command, it's going to create the Argo CD app for you. In my case, I've already done that, and there are no changes on this inside this file. So it's going to show me application.argoproject.io/devops cicd-app unchanged. Okay, but in your case it's going to show this application configured, which means that the application will now appear on your Argo CD UI. Okay, so if you go here, if you just refresh the page after that, you will see this new application created just after you run this command from here. So this is how you create the application on Argo CD. Okay, so after you have done that, now this is our main application that will be used to sync our latest changes and deploy via Argo CD inside the EKS cluster. Okay, so this application has been created inside the EKS cluster only in using this Argo CD. Okay, so next step is, after you've created the application, you can go to the Argo CD UI to verify the application is created or not. You can check that. All right, now you are going to create an SSH key pair on your Bastion host. Okay, so we need that because we'll be pushing some changes to this application source code repository. Okay, so what I'm trying to do here is, from my main repository, when you fork the repository, clone it to your local machine. Okay, then create the application. Then to push the changes to this new forked repository, you will need to authenticate, right, to this GitLab account. So for that, you have to create one SSH key pair using this command sh-keygen, generate a key pair, then get the contents of the public key, then go to your GitLab account, to your profile status. Okay, and then from SSH keys option, just paste the public key here and click on add key. It's going to add your SSH key to this GitLab account, and then when you are doing a git push, git pull, then you will be able to authenticate to this GitLab account without any issues. Okay, it is for that. Okay, so if I just show you here, from here, if you go to profile, on the left hand side you will see SSH keys, and you can see some keys already added to my machine. Okay, similarly you can click on add new key and add the public SSH key here after you've generated it using this SSH keygen command. This is the command that you have to use, sh-keygen here, like this. It's going to create a SSH key pair for you. Okay, but I'm not going to do that because I've already done that, and it's going to replace the existing keys, so I'll just come out of it. But in your case, you can generate the key pair step by step. Just keep hitting enter after you run the command until you get your prompt back, and it's going to create the key pair for you. Okay, and then just get the contents and then copy it in your GitLab account as I just showed you, add the new key, and it's going to store your SSH public key to this account, and then you will be able to authenticate to this GitLab account while doing a git pull and git push. Okay, so that's why I mentioned it here. Okay, so it's like an additional step I mentioned, but it's actually very useful if you do so. You don't have to enter your ID and password each time you do any git pull or git push command. Okay, after that, now, so we have done a lot of the work already. Okay, I mean, most of the work has already been done. Now, since we have a GitLab based CI/CD pipeline that is fully automated, we will add all the relevant environment variables to our GitLab project. So whatever different tokens and access keys we have generated, now is the time to add to our GitLab account, so that when we run the pipeline, those values are going to be picked up by the pipeline stages and authenticate and perform the execution of the stage steps. Okay, so how you're going to do that? So let's go to home page from here, then go to your this personal space and go to your project. In my case, it is CICD new. After you are at the root of this project, your main project, then you have to go to settings, and then you have to go to CICD option here. Okay, same I mentioned in the document also. After you are at the root of the project, okay, you have to go to project settings and then go to CICD, and then you will be able to add the variables. How? I'll just show you. From settings to CICD, and then first thing is you have to go to variables option here. In variables, just choose this owner field here, so that all your pipeline, the pipeline will get the access to use these variables. Okay, so you have to use some permission, so I'm using owner permission here. So just click on owner here and click on save changes. Okay, I think by default it will be no one allowed. So you have to change it to owner and then save changes like this, already given in the screenshot also. Okay, and then you have to add all the different environment variables one after the other. Okay, so argocd underscore password. So I'll just show you how I have added. If you go to variable section like this, so you can see all the variables I have added. Okay, the screenshot is also there in that instructions manual. Okay, so you have to add all these environment variables so that your pipeline can use this to authenticate to different platforms and execute the steps without any issues. Okay, so here also I mentioned one after the other. Argocd underscore password. Argocd underscore password is a server's password for admin user, which we generated in the earlier step. Okay, if you don't remember, you can just search in the same document. Okay, so let me just show you here also what we did. If I go to history command, you can show that, you can see that. So this was the command we ran to generate the argocd password. Okay, so you have to just run this command, hit enter, it will give you the argocd password, which is up to here. So this is the password. What you have to do is you have to go here, click on add variable, and click the name as it is, like argocd underscore password. So it has to be exactly the same. So just add this name argocd underscore password here and here, and the value will be the value which was generated after we ran that command, this command. Okay, so this is the value of the argocd password. Okay, and then just click on add variable. Okay, it's going to add the variable, and similarly you have to add all the different variables. Okay, so each variable that you need, I've already mentioned, argocd underscore server, it's going to be the load balancer DNS name. Okay, so from here you can just copy this DNS name of the load balancer, and once again copy it as value to the environment variable argocd underscore server. Then you have to use argocd underscore username, which is admin in our case. Okay, so all these values you have to add one after the other, just like I did here. Okay, so you have to add all these variables one after the other. Okay, so just add all these. Okay, if you have any issues with any of the variables, just let me know. Okay, I mean I've already covered all the things already, so you just need to add these to your CICD project in GitLab. Okay, once done, step 10 is to test the DevOps CICD automated pipeline deployment. Okay, but if you have not configured your Git on your Bastion host, you can run this command to configure the Git. Okay, with your name and email ID, so that when you run this git pull and git push commands, you don't face any issues. Okay, so it's again like an additional step that I've given here, but it is always useful to configure Git globally on your machine with your username and password, so when you run the git pull git push commands, you don't face any issues with authentication. Okay, so I've given the example also how you have to add it, so you can use this from the screenshot and save and quit. And then it's time to test the pipeline. Okay, so here I am. I'll go to the root of the project. Okay, so these are the files, and to do a sample change so that the pipeline can be triggered, I'll just make changes to this Docker file. Okay, so you can make any changes. Okay, so here you can just add any commented line like this, like test. All right, then just save and quit, enter, then git add Docker file, git commit -m, and just write test maybe, and then you can do git push. Okay, I think I have some unpulled changes in the repo, so I'll just do git pull. Okay, maybe I need to do git rebase. Let's do git rebase. First I'll do git stash to stash my commits, and then do git rebase. Okay, successfully rebased. Now I will just make the changes again. This is a very common Git issue. Okay, so let's just do testing, save and quit. Git add. So I'll just add this Docker file. Git add, git commit, and then git push. And it's going to push the changes to my GitHub repo, and it's going to automatically trigger my CI/CD pipeline. Okay, so let's test the pipeline now. Let's go to my account, go to personal, and click on this CI/CD new, and you can see the pipeline has already triggered. Okay, the test, which is the name of the commit, you can click here and you can check the pipeline. Click on the pipeline ID, and it's going to show the steps. Okay, it's going to take a little bit of time to complete the steps, like 5 to 7 minutes, and these are different stages that I have in my GitLab pipeline, as I explained in the application architecture. So till the time this pipeline is getting executed, let's take a look at the .gitlab-ci.yml file in the project. So this is the file that has our stages. So here, as you can see, I'm using some local variables here, image underscore tag. So I'm going to tag my images, each image that I build as a part of this deployment pipeline. I'm going to use the CI commit short SHA, which means that the commit hash that I have from the GitLab server, I'm going to use that with a variable image underscore tag. Then I'm going to use another variable called ECR underscore image, and this is going to be a combination of my ECR registry, which is a variable which I've already saved in the CICD variable space. Okay, and then I'm going to use a slash, and then I'm going to use ECR underscore repository, and then just add this image underscore tag to the this ECR underscore image. So this is going to be my final container image tagging strategy. Okay, so this is the tag I'm using to create the different versions of my container image. Okay, so so I'm going to use this local variables here, and then I'm going to define my stages. First one is the platform check, then validating the Docker file syntax. Third stage is going to be the build my Docker image and package it. Okay, and then push it to ECR repository, and then scan the build Docker image, and then deploy it via Argo CD to EKS cluster. Okay, these are my different stages. So platform check, as I mentioned, it's going to check the status of your cluster. Okay, so EKS cluster status should be in ready. So this is a script that I'm using to find out the current status of the EKS cluster and check if the cluster's status is healthy or not. Okay, so you can just go through these commands one after the other and let me know if you have any doubts. I can just give you the explanation of all these commands. Okay, if you have any doubts, let's go to it. So this is my stage 1. Stage 2 is validate. Once again, I'm using one image which is going to check the syntax of my Docker file. So it's going to create a temporary container using this Docker and command. So it's going to check the syntax of my Docker file and then delete the container soon after that, after it has validated the Docker file syntax. So this is my stage 2. Stage 3 is where I'm trying to build my Docker image. So I'm going to build and I'm going to push my image to ECR. So to push the image to ECR, I need to use this AWS ECR login command, okay, which is given on the ECR registry. But you can copy the same command from here, and if you define these variables, AWS default region, which is US East 1 in my region, in my case, and ECR underscore registry is also defined as part of my CI/CD pipeline variables. So you can use the same command, okay, and it's going to work for you also. Then I'm going to build my image with the tag. As you can see, ECR underscore image is the tag that I defined initially. So this is going to be my tagging strategy. So each image that I built is going to be tagged with this ECR underscore image variable. After that, the image is going to be pushed okay, to ECR repository after I've been able to log in using this command to my ECR account in AWS. Then it's going to scan the image. Okay, so scan stage is going to scan my container image. Okay, so I'm using snyk open source server, and I have already generated the snyk token to authenticate to the snyk server and perform the scan on my container image. Okay, so I'm going to use these different commands to install npm first, and then npm is going to use to install snyk, okay, inside a container as part of this stage. Okay, I'm using this image, which is a Bhavuk M Snyk AWS CLI. So this is the image that I created myself because I was facing some issues with the default image. So I did some research around this, and I was able to fix some bugs with the Snyk image, the official Snyk image. So you can use the same image. It is there on my Docker Hub. So you can use the image to perform all these steps. Okay, so you're going to install snyk inside this image, and then you're going to run the snyk commands to authenticate the snyk scan using snyk underscore token environment variable, which again I've already defined in my CICD variable section in the pipeline. And then I'm going to run the scan on my image. Okay, and here if you see, I'm doing allow underscore failure true, which means that if I see any security vulnerabilities after this step, okay, ideally the pipeline should fail because there were some security vulnerabilities. But in my case, I've just allowed it to fail. So allowed failure true means even if we have security vulnerabilities found, the stage is still going to be passed, and we can use this as success. Okay, so since it is not a real time I mean real-time production project here. Okay, I mean it is like a this real-time production gate project, but it is still in my home lab. So I've just used this allow underscore failure set to true so that I can pass this stage to go to the next stage. Okay, but in real world you will not have this option. So the pipeline will fail as soon as it detects any security vulnerabilities, and you have to remediate those vulnerabilities first, fix it, and then only you can move on to the next stage. Then the last stage is where I'm deploying this newly built and scanned image to my EKS cluster. Okay, so what I'm going to do is I'm going to use Argo CD to do that. So Argo CD is going to again authenticate to a GitLab. Sorry, this GitLab is going to authenticate to Argo CD, and then it's going to sync my changes, my latest changes to this Argo CD platform, and deploy my changes there in the EKS cluster. Okay, so this is what the last stage does. And if I go back, you will see I'm using a script also, which is sync.sh. Okay, so it has some steps related to this last stage in the pipeline. So let's see that also. So if I go here, I can go to this snyk.sh, and you can see some stages related to Argo CD. Okay, so what I'm trying to do is I'm trying to use the Argo CD username and password to authenticate to Argo CD and perform the sync with the existing application that I have already created earlier on. Okay, so I'm going to use this Argo CD app sync command to sync my changes to the latest one, and to sync the changes to the existing application in the Argo CD. Okay, so this is what this script does. Okay, so I hope you you were able to understand all the different stages within the stages, all the steps. If you have any doubts, you can always reach out to me, and I'm going to answer all your queries. So now let's check the status of the pipeline. As you can see, the pipeline was succeeded. Okay, if I go to this pipeline ID also, you can check the pipeline ran successfully and all the steps were deployed. Okay, and if I go to my Argo CD, if I just refresh, you can see the status of the pipeline. You can see it has been just synced 5 minutes ago. Okay, which means that all my latest changes were synced to this application on Argo CD successfully. Okay, so it just succeeded 6 minutes ago. Okay, so this is how a real world production gate pipeline looks. Okay, so these are different stages that are there. But yes, I mean, different companies have different stages, but this is what I have experienced in my real world projects. So I just wanted to give you a very good introduction into how you can actually deploy this type of project in your home lab, and get some hands-on experience that is required for your DevOps and SRE interviews. Alright guys, I hope you liked the video. That's all that is there to it. If you liked it, please hit the like button. I request please subscribe to my channel, and please share this video with your friends and colleagues. Alright, that's all for this one, and I'm going to see you in the next one. Bye for now.